Okay. So yeah, thanks again for inviting me. It's a pleasure to attend, even if virtually, for the first time, and to give a talk. So today I'm going to talk about something that is a little different from my sort of usual line of research. It's just an important topic which we all need to worry about, and it's about agreement in human evaluation. And the reason I want to talk about it is partly because, like I said, it's obviously relevant, but partly also out of frustration on how people seem to perceive the need for agreement analysis, and also, or mainly, acceptable levels of agreement in every single form of human evaluation or data annotation, regardless of the several variables that are involved in this process. And in this talk, I'm mainly going to talk about the task at hand, so the core task that we are annotating or evaluating data for. And a bit of a warning, this is one of those talks that doesn't offer a solution, so we'll highlight a few issues, which in this case are mainly to do with diversity of the tasks and their complexity and subjectivity, and which make the point on why high agreement or agreement altogether is not necessarily something that we can expect. So this will be sort of a mix of stream of consciousness and some examples of how we look at agreement in ours and other people's works. And we hope that we start some dialogue on the topic and have some interesting discussion. I'm going to get started, and just thank you to some of my students and postdocs who helped me put some of these numbers together for the presentation and did most of the work. Right, so I'll start with the scope on what I mean by annotation here. So I'm using this as a very broad term that refers to essentially the process of manually creating data for any sort of, not only machine learning, but generally as a machine learning approach, be it for evaluation or for essentially training data, creating training data. So, and then the data could be used for either proper training or validation or test. And sorry, if I say evaluation here, I'm talking about human evaluation. Could be absolute or relative terms, so it could be comparing different sentences or just giving a score to sentences or text or any sort of a unit. And the evaluation itself or the annotation can be done by professionals or volunteers or crowd work. So it shouldn't matter in principle, the point that I want to make here. So I'm just going to keep using the word annotation to refer to all of this. And generally, when we're creating data, we obviously know that we have to try and ensure reliability of the annotation. And an important factor there is certainly the quality of the human annotator or annotators who are doing this, who are creating the annotations. And this involves several questions that we have to answer. Does the human annotator have the right skills to perform the task? Does he or she understand the task, understand the guidelines? Can they follow the guidelines? Are they potentially cheating, especially with crowdsourcing? Are they taking shortcuts, mainly due to tiredness, and so on? And there's various related questions here. And then obviously there's also other aspects of it, which are more related to the data and how we select the annotators to make sure we don't introduce biases, but I'm not going to focus on that part. And in general, one thing that we try and do to minimize biases is to have multiple annotators. And if we're careful enough, we try and select them such that they have diverse backgrounds and so on. But the idea of having multiple annotators is sort of understood as a good thing to do, even if you're not carefully ensuring their diversity and so on. So the way we try and look at this different tasks that are listed, we can sort of broadly group them in two groups. The first here in yellow, I would sort of refer to them sort of pre-task. So essentially you are preparing the task and the annotators. So it could be training the annotators, it could be refining the guidelines over a few iterations. It could be running qualification tests to make sure the annotators can actually do the task. And once this is done, then you move on to the actual task. And that doesn't mean that you have to stop worrying about reliability. So we can do things like quality control as the data is collected. For example, if you use crowdsourcing platforms, it's common to have a subset of Go data, or very obvious cases where you can upload the labels to the platform and then make sure the annotators are actually getting those labels correctly. And if they're not, then you know that something is wrong. So this is sort of a more continuous process that you can still do while the annotation is being collected. And this last part, quality control, is a big problem, not only for crowdsourcing. It's an important step that a lot of us sort of tend to disregard. Once we do the preparation for the annotation, we tend to just say, all right, now we collect the data and we assume the data is what it is. But when it comes to quality control, there's two questions that we need to sort of ask every time we design an experiment. The first one is it feasible to start with? If you have a very large data collection, then creating enough samples with code annotation may be a bit expensive or too expensive to do. And in some tasks, having these obvious cases where you can automatically label the data is not very easy to do, or it's very easy to detect by the annotators. For example, if you're evaluating machine translation, one obvious case, you could shuffle the translations with respect to the sources. So you're giving a translation for a completely different source sentence to a human annotator, and you're expecting some judgment on quality there, which should be very low or should be close to zero if you're rating this on a 0 to whatever scale. But this is very easy to detect. So if you're worried about cheating, this is not going to be very helpful. So ideally, you should actually have code data, which could be very expensive to collect at large scale. And the other question is this enough? So for some tasks, it's quite hard to think about a code answer. For example, if you actually asking annotators to produce a translation, and you want to give a code translation as a way of doing quality control, this is nearly impossible because there are many possible ways in which you could translate a source segment, especially if it's a long segment and so on. So what we tend to do is actually add another level of quality control on top of this ongoing quality control that happens during the data collection, which is generally the agreement analysis, which is not a problem by itself. And I hope you get my point here. So we do the preparation, we do the quality control throughout the annotation process. And then after that, we measure the so-called agreement in different ways. So, and this is obviously based on the assumption that we will have multiple annotators, at least for a sample of the data. And therefore we can look at, make them annotate a subset of the same data points, and then we can measure inter-annotator agreement. We can obviously also make them annotate the same data points among themselves. And in that case, we can measure intra-annotator agreement. And if we have the resources, obviously we can get them to annotate the entire data set, but this is generally not the case. And this is a point I'm going to go back to towards the end. So the common assumption in this case is that whichever metric of agreement we're using, if the annotators agree, we assume that the guidelines are good, that the training that we done, the preparation was effective, the annotators didn't cheat, and so on, and therefore the data is reliable, and we're happy. However, if the annotators disagree, we assume that something went wrong in this process. We may not know exactly where, but something went wrong, and therefore we assume that the data is not reliable. And if we're submitting this to a conference, chances are that someone is going to pick on that and is going to use it as a reason to reject your paper. And that's where my sort of frustration starts, not only out of getting papers rejected, but out of the understanding that people have on this need for agreement. So my claim, which hopefully will become a little bit more obvious or clear soon, is that agreement, or at least the expectations on sort of high agreement levels, should not and cannot be expected for some tasks. And that this expectation will depend on various aspects, which I list some of them, which I think are the main ones here: task complexity, subjectivity, and also the label type, which is slightly, these are all sort of related but slightly different takes on the diversity of tasks. And then obviously also the data type. You can have, for example, again, in the translation evaluation, you judging the quality of the translation, but you could have errors in the source text. And how do you go about assessing the translation quality in this case? It could be that there's, it's also a function of the amount of training that you give to the annotators. It's also obviously a function of the quality of the annotator. But this tends to be the only variable that is really considered and tends to be what we blame. I mean, annotators tend to be what we blame when things go wrong. So in the previous slide, when I say something went wrong, in a lot of cases, especially with crowdsourcing, we say that blame is on the annotators because they didn't do a good job, either because they cheated or because they didn't understand there were perfect guidelines, which are not always perfect. And obviously the approach to measure agreement could also be different. Some people just take the favorite metric, kappa, and apply it to tasks where it doesn't make sense. But I'm not going to go there today. I'm just going to show you some different ways in which we measure agreement. But this is, again, very task dependent. So in the rest of the talk, I will talk a little bit about these 3 items in blue here, which are all related to the task itself, the task at hand, and give some examples of tasks where we have high complexity, high subjectivity, and also where the labels, the type of label, make a huge difference. And I'm not going to go into detail in terms of what metrics we use for agreement, but some of the metrics that we're going to cover here are standard ones that people are probably familiar with. And the general assumption is that we want to measure whether 2 people produce the same annotation for a set of data points. Kappa is the one that probably most of you will know. And it's essentially just looking at the proportion of labels that are the same, discounted by some estimate of a probability of agreement by chance. So P of A here is the probability of agreement, so proportion of agreement, I should say, and P of C is the agreement by chance. And this works fine with obviously discrete label tasks, but not with continuous label tasks. So for continuous labels, we tend to use other metrics. For example, we can measure the correlation between the sort of the code, or sorry, the labels of different annotators, or we can measure the distance between the labels of different annotators. And then obviously if you have if you have string based tasks where the label is actually a string, such as the task is to generate translations or simplifications, then one can think of metrics that measure some form of a string distance or similarity between the different annotations from different annotators. Right, so I'm going to move on to this 3 things that I want to talk about: task complexity, subjectivity, and label type, and give some examples for each of these. I'm going to start with complexity. And I have, like I said, different tasks here, different annotation tasks, I should say. I'm going to, start covering them and see how far I can get. So the first one is, the 2 first ones are to do with translation, and the last one is text simplification. So let me start with translation quality. So for those who are familiar with machine translation and how we evaluate our translation systems nowadays, we essentially rely on human annotations for that, or human evaluation, using this metric called direct assessment, which is the main metric at the WMT conference or evaluation shared task. And there we ask translators to rate a given translation, either with respect to the source sentence or with a reference, in this range of a 0 to 100, using this sort of slider, which is on the screenshot, without any specific guidelines. The question is just sort of how accurately does the candidate text convey the original semantics of, in this case, the reference text. And this has proved to work fairly well in crowdsourcing settings. I'm not going to talk about evaluation here because Yvette, who proposed this metric, doesn't go there. She essentially sticks to the fact that you actually need multiple labels, a relatively large number of labels, 15 to 16 per instance, to get a measurement that is reliable. And then what she does is to just take some mean of these multiple annotations, which is somehow normalized by annotator variance. So it's a sort of a Z normalized mean of all annotators. And then that's it, that's the annotation. We try to make this DA annotation a little bit more informed to actually look into whether translators can do it in a way and where they agree. So essentially we took the same range, 0 to 100, and we call it guided DA, but we proposed guidelines, and this is based on some previous work by colleagues at Facebook, where we're essentially saying you still have some flexibility in this 0 to 100. So we split it in bins. From 0 to 10, we say it's an incorrect translation, could be completely incorrect, so 0 or somewhat have some words that are correct, and so on, all the way to 90 to 100, where you have a perfect translation. So we allow for some flexibility, but we fix the bins essentially. And we collected a lot of data for various language pairs, 7 language pairs, so 10K per language pair, and then we had 3 annotators. And we sort of forced, as part of quality control here, we forced the annotators to somewhat agree, meaning that we only allowed them to disagree by 30 points. The way we do this, there is a tool that when we have multiple annotators and we make them create these labels. If they disagree, we actually pull a different annotator to do that until we get to 3 annotators that agree by or that don't disagree by more than 30 points in the 0 to 100 scale. So we thought this was pretty good, and we're going to get a data set with high agreement. When we actually measure, and remember this is a continued score, so we measure, what we do here is essentially we take the mean of the 3 annotators and we measure standard deviation. So if you look at this orange bit of the table here, what it's saying is that for different language pairs, let's say English, German, on average, the 3 annotators deviate 13 points with a standard deviation of 8. So actually, even though we control them within the 30 points disagreement, we're still getting about 20 points disagreement in a lot of cases. So this to me is just showing that this is a very complex task where agreement is a tall order to expect. And this, by the way, we're all professional translators doing the annotation. Now, turning the dial a bit up on the complexity here. This is a new task that I'm still working on. It's very exciting, but very hard to define, but also very hard for the annotators. So this is a task where, again, it's machine translation, but we ask annotators to detect and mark the spans of one very specific type of error, which I call catastrophic errors. Some people call them critical errors. And we define this as errors that deviate in the meaning from the source sentence, that are misleading, or and may carry some health, safety, legal, reputation, religious, or financial implications. So these are errors that are pretty serious. and they're all meaning errors, and we divide them in different sets. But just to further explain it, they can be mistranslations, or you can add words, or you can delete words, but these are all meaning related errors. And we use some annotation tool, which I'm just highlighting here to do that. And we have this 5 categories of catastrophic errors. And then we ask them to not to annotate any other errors, just these errors. And the types are, for example, toxicity, where the machine translation introduces or removes some toxic words. Safety, when we introduce or remove or change something that could lead to safety risk. Named entity, sentiment changes, or unit or time or date or number changes that could, for example, lead someone to go into the wrong place. So it's a direction and the kilometers are translated as miles, or there is a time that is translated incorrectly and someone misses a meeting because of that. So this is some examples of these categories. Some are pretty obvious, like the toxicity. So the green here is correct translation. The red is what the MT produced. The safety one is an interesting one. This is a real case. Wash your hands got translated as shake hands in the COVID era, so that's not a good thing. And so on and so forth. So obviously in these examples, things work very well because everything else is correctly translated, and I just have these errors that are sort of plugged there. But in real life, this is not the case, because there will be other errors that are not critical, that interfere with the sentence understanding. And in some cases, the sentence is quite bad and cannot be understood altogether. So we did a lot of work on sort of refining guidelines and preparing annotators for this. I've been working on this for over a year and a half now, and I don't think we have something that is as good as I would like it to be yet. Again, we're working with professional translators on a number of languages, on sizable data sets, and on the data that I'm going to show here, this is part of the training and the sort of pilot, where we looked at 9 annotators. And then for the actual task, we're doing it with 3 annotators per task and language pair. And like I said, there's various issues that make this complex. And some of them are to do with the actual categories. For example, wash your hands, don't wash your hands. This could be seen as a safety risk, but also as a change in the sentiment. So some of this is to do with making sure the guidelines are very clear, which now I believe they are, but others are to do with the complexities of the inherent complexity of the task. And when we talk about agreement for this task, we have 3 types of things that we want to measure. One is whether annotators agree on the existence of errors and the number of errors. So they might agree that, yeah, the sentence has at least 1 error, or that the sentence has 2 errors or 3 errors and so on, or that has no errors. On the types of errors, so is it a toxicity error? Is it a sentiment error? And also on the span of the error, which span of words make for that error. So like I said, this is a small pilot with 9 annotators, and we're actually doing this for a lot more data in the real task. So let me just show you some very simple numbers to emphasize how difficult this is on the three types of agreement, starting with the existence of errors. So this is for one of the language is English, Chinese. And the values here are simply the proportion of annotations out of this 100 that annotators selected to have 0 errors or 1 error or 2 errors. And as you can see, there's some difference that I haven't highlighted here. For example, annotator 9 here tends to think that there are a lot more sentences with one error. There are other things, other labels that they use which are not here, which are the source sentence is unintelligible, or target sentence is completely unintelligible. But it gives you a feel for the disagreements here. So, for example, between 3 and 4, they disagree a lot on the existence of 1 error, and annotator 4 tends to think there are a lot more sentences with 1 error than with 0 errors, and so on. So there is a lot of disagreement here, especially for the one error and then 2 errors. There are very few sentences, and this is sort of the basic level of agreement that we would expect. Do they agree there is a critical error in this sentence, or 2 critical errors, and so on? And as we move on to the more fine-grained disagreement analysis, so the next one is on the type of errors. So whether it's a toxicity, safety, and so on, or whether we have this sentence level labels where the source is unintelligible, or the MT is unintelligible, or there are no critical errors at all. But if we stick to the blue ones here, we can see again, if you look across columns here, we can see significant disagreement, for example, on the named entity from 2% to 20%. On the toxicity, we have 10% in one case, and then 0 or 4% in other cases, and so on. So a lot of disagreement here. And even though I said this was part of a pilot, this was not the first round of annotations they've done. They had done another round before this, and we still had significant disagreement. And then when we look at the spans, these are 2 sentences. Each row of each of these tables is one of the 9 annotators, and each color corresponds to a different type of error. For example, red, I think, is toxicity, if I'm not mistaken. If there is a green across, it's because there are no errors. If there is a brownish across, it means that the source is completely, or the target is completely unintelligible. So again, you can see that in the first case here, there's some agreement on 1 error, although the span varies a little bit. The purple one goes a bit further. There's disagreement on the yellow error, which is only annotated by 1 annotator. And some annotators seem to think that either the sentence is no errors or the source is not understandable. And there's another nicer case where they all seem to agree on some probably more obvious error here, and then one of them also annotates other errors. But this is a very, very hard task, and I'm not going to show you some numbers here because this is ongoing on the final agreement. This will come up as part of the WMT shared task on quality estimation this year. And if you're curious about the data or want to learn about it, just send me a note later or ask questions. Given the time, I'm just going to skip simplicity, but I'll come back to it later if we have time, because I wanted to talk about the second element of why measuring agreement is difficult and may not be feasible, and well, high agreement is not to be expected in some tasks. So the other one is task subjectivity. Again, this is related to complexity, but as hopefully you see that in subjectivity, the task definition is in principle simple. The guidelines are probably going to be simpler, but yet there are other factors that will influence the decisions of the annotators, which will make agreement something that you cannot necessarily expect. So it's a different view of the problem. And I'm going to talk about 2 tasks, toxicity and funniness judgment. Probably I'll stick to the main one, the first one, sorry, which is our own work. So toxicity here this is a data set that we've collected and we're releasing. And the task is it's a binary classification task where we ask annotators to give a label 0, 1, where 1 is this segment is toxic and 0 is it's not toxic. We define toxic in a very broad way to include hateful, offensive, and bullying, and so on. And we take data from Reddit, so from some popular subreddits. We use Amazon Mechanical Turk for that, which is different from the 2 tasks that I described so far, which were all done with professional translators. In this case, it's not translation, but it's done with a crowd. And we have 3 annotators per instance in principle, and then we increase this, and I'll show you a bit later. And in this data set, we're also interested in looking at what we call control groups which are groups of annotators that share a particular demographics aspect. And we look at gender, political orientation, and age. And also we are interested in differentiating annotations that have context from those that have no context. So when you say comments only here, it means that there's no context, and context plus comments means that we're showing, in addition to a given comment on Reddit, we're showing the initial post that comment refers to, which will have a title and also an image. We work with images here in all the instances. And altogether, our data has 21,000 instances. But obviously, this is aggregating all of the annotators and all of these control groups. So just to give you sort of a feel for what the data looks like, without any looking at specific controls here, 35% of the instances without any aggregation by all of the annotators are judged to be toxic. And then if we start looking at aggregation strategies, which is given that we have 3 annotators per sample, if we look at the majority vote, in this case, 2 of them have to say that it's toxic, the number goes down a little bit to 30%. We also asked them to indicate their confidence in a 1 to 5 scale. And if we look at the ones within this 30%, if we look at the ones that are high confidence, we get, again, 30% of that slice. So kind of narrowing down. But interestingly, if we simply take the 21,000 annotations and we look at the ones where at least one of the annotators said it was toxic, we get a very high percentage of toxicity, 94% versus 30%. So you see the difference here, which indicates obviously that there is a lot of disagreement in this data. And also only 50% of the annotations are said to be fully confident with the highest possible confidence level, showing that even though it's not a complex task in principle, the individuals have trouble deciding on whether something is toxic or not, because it's language, because it could be sarcasm, because the context might not be enough, and so on. And then we actually did this exercise of measuring kappa just for the fun of it, and put it in the paper, and obviously got the usual criticism, the kappa is too low, but I wanted to show it to you here. The paper was accepted anyway, but so if you forget about the 2 groups, just look at this first 2 columns here, which measure kappa, and P of A is just proportion of times the 2 annotators agree on the binary label. But then if we obviously rule out the 50% chance of agreement by chance here, the numbers are much lower. And this is within specific groups of gender, political orientation, and age. But you can see the numbers are extremely low. And obviously this reflects what I've just shown you in the previous slides. And we also tested this with versus without context. And it just turns out to be a bit counterintuitive that without context, annotators tend to agree more. And this just could be because they default to an option of saying something is or is not. In this case, it's actually they default to the option of saying that something is not toxic if they can't see more information about it. And whereas when they have the context, they have a little bit more information to decide, and then they disagree more on their decision. We did another exercise where for one of the groups, for the political orientation group, we actually collected 10 samples instead of 3. So we increased the number of samples, and everything sort of, the toxicity, the non-aggregated toxicity level is still high, or sorry, still the same, shouldn't say high. But the interesting thing is obviously the blue one here, that if we take the cases where at least the instances where at least one annotator says it's a toxic instance, then we get to an even higher number of 99% of the cases. So everything is toxic, which we know is not necessarily the case. So I'm probably going to skip these details, or maybe let me go to it. Yeah, I think what I wanted to show as a point here is that sort of the disagreement remains if you add more annotators. Obviously, if you're measuring the agreement between pairs of two annotators, which is what I do, and then averaging over all of the pairs, the level of disagreement is not necessarily better because you have more annotators, and as I'll come back to it later, probably this is one of the tasks where you should just not expect agreement at all. And again, I'm going to skip this one, which is just another example of subjective task. It's on deciding how funny some text is. And I'm going to move to the label type, which I think is also quite interesting. So now, in principle, tasks can be complex or subjective, but one thing that is a different angle to this problem is the actual type of label that you're annotating. And this is what I wanted to cover here. So agreement normally is done when you're talking about classification, or maybe continuous scores, or so discrete scores or continuous scores, but where you only have one label. But obviously in language, we have a lot of tasks where the labels are not such type, and where the labels are, especially the ones that I want to talk about here, the labels are actually strings. So you actually have a text as a label, and this covers a very wide range of tasks. I'm giving 4 as the example here, but any language generation task would fall into this category. And depending on the type of task here, even though all of the labels here are text, so machine translation, post-editing, I'm asking the annotators to fix the machine translation into another string. Machine translation itself, I'm asking the annotators to generate a translation. Text simplification, annotators will generate a simplification. And image captioning, annotators will generate a description of an image. So even though these are all, like, let's say, sentence level generation tasks, and you could have even more complex ones like summarization, but let's stick to sentences here. There is a difference in the complexity of measuring agreement between this. And for example, if you're measuring agreement between post-editing of machine translation, there's fewer things that editors are likely to do than if you're asking them to translate from scratch, because they already have a prime that they then fix based on whatever errors they decide that there are. And I'm claiming here that image caption is probably the most complex to measure agreement, because essentially you're given an image and there's so many ways in which people could describe an image depending on the things they choose to emphasize or the details they want to talk about or not. And in these tasks and in other tasks where language is generated by humans, using multiple references is a common practice. Yet the expectation is still that the annotators agree, especially in the NLP community. In the image caption community or in the computer vision community, this expectation is not there. But in the NLP, if you collect multiple translations, there's still some expectation that they're not going to be too diverse. Otherwise, our metrics tend to fail, for example, or be inflated or deflated by these references. So let me just go through some of these tasks and talk a little bit about how we measured agreement there, if at all. So the first one is the one that I said is sort of probably the least complex to measure agreement on, even though it's still fairly complex. So this is, we have humans post-editing machine translation, and then the metric here is actually measuring the edit distance between the original and the post-edited version. And the assumption is that the smaller this distance, the better the machine translation. So what we did here in an experiment was with 5 annotators, was to essentially look at this metric, which we call HDR, and other metrics, which is essentially just measuring blue against this post-edited reference, or meteor against this post-edited reference. And the expectation is that if annotators made the same edits this metric HDR would be very similar across different annotators, or even if they made the same numbers of edits. Maybe the edits didn't need to be exactly the same, but if they made the same number of edits, this figure would be similar. And this is just what I have here as mean is the mean aggregated over an entire data set, so it's not on individual data points. And you can see that there's some fair agreement here. Annotator 0, 32, 1, 27, 25, 30, and so on. So this, I mean, it's a way of showing that post-editing it's sort of possible. In the post-editing task, it's possible to expect some level of agreement in the proportion of errors that were edited. Now, if we move to a slightly more, well, a lot more complex task, that of text simplification, we see that the picture is going to be different. So in this case, we collected a data set, this data set called asset, where we as humans should provide simplifications for sentences. And we had over 2,000 sentences, and we created 10 simplifications per sentence. And the guidelines were sort of very well defined. This was crowdsourced. This was all in English, but workers were instructed to use a variety of writing transformations, including lexical, syntactic, so they could replace words, they could reorder, they could change the structure. We just asked them not to add a lot of content and not to remove too much content. But they were sort of free to do a lot of things here. And if we look at some of the simplifications, now, if you just take the top one as the original one, the sort of more complex one, and then ignore the headings here and just take this as different simplifications that the humans gave to the same original sentence. So you see again that there is a lot of variation here. The first one, they just replaced quite small by very little, and then their visual acuity is poor, their sight is inferior. The second one, they actually split the sentence in two to make it more readable and also replaced some words. And the third one did a bit more compression and so on. And the same for other sentences. You see that there is a lot of variation across different annotators. And it's not that, I mean, the trend is obviously not always the same. So one annotator would do certain types of things, but not always the same things, like the structural simplicity here. So splitting the sentence in two, it's not always the same annotators who do that. So if we even think about measuring agreement here, it's pretty much impossible to expect that you'd have any type of agreement here. And then finally, the one that I mentioned, I think is the most complex, would be this, well, vision to language tasks, where your input is one modality and your output is a different modality. So there are other tasks that could fall into this category, but these are real descriptions collected by different annotators on the same image and from the MS COCO dataset. And as you see, some sentences are longer than others. They have more details. One of them or two of them talk about a man. So it's probably talking about the main the sort of character in the forefront here. The other ones, two of them talk about the police officer in the background, and one just sort of generalizes the scene in City Street where a police officer and several people are standing. So people obviously have different ways of interpreting a scene or find different things more interesting to describe. And again, there is no way you could expect agreement in these descriptions. Right, so what? So I've covered sort of various task-related aspects which made it hard or even impossible to expect agreement when humans annotate for these tasks. But what can we do when we have to work with this task and we want to make sure that the data is reliable, and we want to have some way of well, showing this in quantitative terms. So let's just sort of wrap up where we are with these different types of tasks and also complexities and so on. So for what I call language tasks, which are the ones I just described, the ones where humans are generating language, there's a general understanding that you should collect multiple human references or human instances, or sorry, human annotations for each sample. But rarely we do that because this is costly in the NLP community. For example, when you do evaluation of machine translation, we normally do this based on one human reference that is collected as part of the data collection. When we're training the models, we also only use one human reference. And in the few cases where we do collect multiple references, generally for evaluation, I've seen multiple times analysis on agreements between this or expectations on agreement between this. And then for the subjective tasks, such as the ones that I talked about, the toxicity annotation, it seems that we're moving to this point where collecting multiple labels and aggregating them in some way is a common practice. Yet you would be expected to show some form of agreement analysis for your data. So even though you're saying, I'm going to take the majority vote, or I'm going to take, I don't know, whatever aggregation technique, there is an expectation that the annotators will agree to some extent. And then for the very complex tasks, such as the annotation on the critical errors, there's a missing word there, one instance seems to be considered sufficient in these tasks. And you only show agreement on a smaller subset of data. And this is mainly to do with the cost of the tasks. But what I claim here is that this should be treated in the same way as subjective or language tasks, where you're actually collecting multiple samples and then finding ways of aggregating them. So what can we do as a community here? So the main thing is to sort of embrace diversity in subjective and language labeled tasks, which obviously you can only do if you can collect multiple labels for each of the instances. The more, the better. I talked about collecting 3 or 10 or 15 in the case of the direct assessment. We do need to then carefully think about aggregation approaches. Obviously, if it's a continuous score, you might just take the mean or somehow normalize the scores for annotator diversity, diversity, like some annotators tend to stick to higher end of the spectrum, others to the lower end, and so on. But don't expect agreement. I think there's no point in trying to even go there.
So sorry for interrupting. We have to wrap up, really.
Yeah. This is the one before the last slide. So for other, obviously you can also think about this in terms of the evaluation metrics that you're going to build on this data. That's just to give an example. We have an evaluation metric for image caption called VFidel, where it takes the multiple references into account in a way that other metrics don't, but you can ask me questions about that. And as general as dataset creators and curators, we should always take into account the complexity, subjectivity, and label type, among the other things that you know are important when designing the training, the quality control, and the agreement analysis, if it's supposed to be there, or the aggregation strategies. And as paper reviewers, which we all are, don't be too obsessed with the idea of that high agreement is needed. Just try and think about whether it's possible at all to be measured for the task. That's it. Thank you.
Thank you very much for an interesting talk. And sorry for not giving you more indications about the time. I was just letting you to talk, and now we're actually at the end of the session. So there would not be a lot of time for questions now. So what I can propose, well, first, thanks again for the presentation, but I